Assalamu alaikum. My name is Dr. Saqib Iqbal and welcome to lecture number 7. Today we'll be continuing with the previous lecture, what we studied in the previous lecture, and we're gonna look at the implementation of abstract classes. Before moving on to the implementation of these abstract classes, I'm gonna recap what we studied in the previous lecture. We looked at some examples of interfaces and inheritance, and we saw that how you can implement these two constructs in Java. And we also saw that there are some keywords which you can use to make your code more understandable and more consistent. We also saw that there are different kind of rules which you should implement while you are developing a system using interfaces and abstract classes, and also the inheritance. And we saw that you can have multiple interfaces for one class, and you can also have multiple parent classes for one interface. We saw that in the interfaces you should not implement the methods, you should just write the names of them. And what you do is that you write their implementation in implementing classes, which you declared with implements keyword in the code. We also saw that in inheritance, what you do is that you write extends keyword with the classes, which means that you are making a class a child of a parent class. So this is an example of generalization, where you have got a specialized class which is realizing a general class. And I told you in the previous lecture, what you can do is that even if there is no generalization in your code, you can introduce on your own. What you can do is to try to find a shared behavior in all the classes, and then try to come up with a name which shows the similar nature of all the classes which you are going to make specialized classes. Then you can name that generalized class, and you can make it a parent class, and you can keep the similar behavior which its children classes are going to use in the parent class. And there is another rule which you can implement, is that overriding of the classes. What it means is that you can not only use the method as it is from the parent class, but you can also add some behavior to it. You can also add some lines of codes to that method. And then this thing is called overriding subclasses. Now, overriding means that you are taking a code from the parent class, but you are overriding it with some additional behavior. You can, of course, write some other methods in subclasses as well. So you are not only bound to use the methods which are written in the parent class. So you can do the same thing with interfaces as well, that you have to implement the same methods, but you can, of course, introduce your own methods as well. So in this lecture, what we're gonna do is that we're gonna talk about interfaces again a little bit while we are talking about abstract classes, and we're gonna also talk about some reference data types which are used in the abstract classes. And abstract classes in general, we're gonna see their implementation, how you write their code, and the overview of the generics in Java, which we talked about in the previous lecture, but we didn't cover it. And the reading, of course, is the same, that you should find the material about all these concepts in Java tutorial. You can go online on the Oracle website, which is the principal organization that owns Java. And you can also look at more stuff in object-oriented programming concepts on internet. And of course, you can consult Wikipedia pages for these constructs as well. Okay, what are the abstract classes? Before going on to their implementation, I'm going to repeat that concept. That abstract class is the view of the classes from the designer's perspective. You don't look at the details of the classes, rather you make an abstract class to look at the system from a view where you are only looking at the type of classes you are going to have in the system and the type of methods these classes are going to have. Now remember, how it is different from interfaces is that it can have implementation of some methods, but that implementation is always incomplete. Either it is missing or it is incomplete. Okay, why you do it? Because it provides you a bird's eye view of the system. You don't know about all the attributes, all the implementation details, what kind of logic codes you have written, what kind of lines of codes are included in the system. What you do is that for designing purposes, you just look at all the classes, how they are written, and what is their architecture, how they are interacting with each other, what kind of inputs they are taking from external systems, or what kind of inputs they are giving to the other classes. So basically it provides you a designer view, and you can also discuss it with the clients, and you can show them the architecture of the system using abstract classes. And another benefit of using abstract classes is that you can declare abstract classes, but if you don't want to write implementation in the parent classes, but what you want is that the children should have its implementation. I'll show you some examples in Java code, and that will make you understand this concept better. But what you do is that you simply write a keyword with a class, abstract keyword, and then you don't have to write its code. If you want to write it, it's up to you. That could be overridden in children classes. But if you don't want to write it, then at least it can give the children classes a way to implement or override the methods which are written in the parent class. So sometimes it's appropriate to partly implement a class or interface. Abstract classes allow code to be reused in similar implementation. Abstract classes may include some abstract methods as well, and remember, you have to write the same keyword with them, the abstract keyword. If there are no abstract methods, then the class is usually, but of course not always, implemented fully enough to be used by an application. Sometimes it is helpful to have multiple implementations that differ only in their type, but this is quite an advanced concept in the design. So first we're going to only look at the simple concept of abstract methods. Okay, now this is an example. This is an abstract class. So how we are declaring it is that we have written a keyword public here, which shows that its access type is public. Any other class can access it, and it is an abstract class, and its name is myGraphicObject. And now you declare its fields. These may be non-static, it's up to you, like private, integer, x and y. And then you can declare non-abstract methods as well. And then you can declare the methods which must be implemented later, which are abstract methods. So basically it is just like a class. But if this class is going to have a single abstract method, then you should declare it as an abstract class. So what it means is that it will act just like a normal class. You can make its object, you can instantiate its instances, and you can also access its methods using those instances. But what you do is that you add some methods which in this, those methods are not going to be implemented in abstract class, but you want the children of this class to implement them according to their own need. So in this myGraphicObject, you know that in graphics you are going to draw something. So this abstract draw is an abstract method in this class. So now this is a generic class. If you look at this is a myGraphicObject. Now whatever object you want to make, if you're implementing a system which is going to have a lot of graphics in it, and it is going to have a lot of shapes in it, so whatever the shape you are going to implement, you will have to have a different class for that, and that class will be a child class of this class. So that class will, what actually it will do is that it will take this draw method and will implement it according to its own need. And similarly the other child can implement it according to its own need. Okay, this is the example of that. That in the design view, if you look at it, you have got a shape class. These are all its different methods which are implemented there, but there is a draw abstract method. Now these are the children classes of this parent class. Now if you look here, these children classes have also got the same method with the same name and with the same parameters as well, draw, G, graphics, and all these different classes, the parent classes, have got different purposes of using this same method. For example, the circle class will use it to draw a circle. Similarly, rectangular class will use it to draw a rectangle, and so the triangle class. So their implementation is going to be different. So this is the benefit of having an abstract class, that in the general class you don't want its implementation, because the general class name is shape. So shape, it could be any shape. So you don't know what kind of shape you are going to implement. So the draw method is not going to have any implementation in it, because you have not defined what kind of shape it is going to be. But in the children classes, you have clearly mentioned that triangle class will only draw triangles, rectangle and circles will only draw rectangle and circles. Okay, this is the code for that. In the rectangle, you have got this draw method, and this draw methods will draw the rectangle for it. And similarly, in the circle class, now look at the code, how they are extending shape. Extends means they are inheriting shape's behavior, and they can have their own implementation. Okay, so these three classes can have their own implementation of draw method. Now we go on to another keyword, which is final. Now, as the name suggests, final is any variable or any value of a variable which you want to keep final, and you don't want it to be changed during the execution of the program. Now, final could be attached to a field, to an argument, to a method, or to even a class. So what it does is that it can prevent the extension or the overriding of a field, argument, method, or class. So if you look at these examples, that if you are declaring it with a field, then field will become constant. If you are putting it with an argument, then this argument cannot change the data within the called method. Okay, this is a little complicated concept. You know what arguments are? Arguments are the data which you pass in a method. When you are calling a method, and if that method body has got parameters in it, for example, if I show you this example of a method, now this method, for example, draw, has got an argument graphics. So this argument G is a graphics type. Okay, so these are the arguments. So if you make an argument final, then that argument is not supposed to change any data within the called method. Okay, so that argument will only contain the value which was assigned to it in the beginning when you wrote the code. Similarly, if you put the final word with a method, then you cannot override the method in subclasses. This is again an important concept. What it means is that I told you that if there is a method in the parent class, you can take it and you can override it. Override means that you can write it with the exact same name, but you can add some behavior to it. But if you have written a final keyword in the parent class with that method, then you cannot change it, or you're not supposed to change it. If you changed it, then you're going to get a compiler runtime error. Sometimes it is required according to the application needs or the development need, or if you want your whatever the implementation of method is doing, if you want to preserve that, and if you don't want children to change it, then you can write final keyword with it. But you should always be careful using this kind of keyword, because it is going to bound you from using the same method. Okay, and by doing the overriding thing. Okay, so you can also put it with final, cannot be subclassed. If you put it with a class, then it means that you cannot make its children classes, you cannot make its subclasses. Okay, sometime it is always, it could be required, or it could be needed, that you don't want a children classes of a particular class, because you don't want the children to override the methods, or you don't want children to use the methods, or if there is that kind of situation where you don't want to implement inheritance, or you want to avoid a single class to participate in any kind of inheritance, then you can write this final keyword with the class as well. So as the name suggests, final means that whatever the condition this argument, this field, this method or class is, that you should keep them in that condition, and you cannot change their values. Okay, there is an example that you have got a chess algorithm class which provides you a method to play chess. Now in this you have implemented next move method. In the next move we have put final with it. Now by this final, what we are suggesting is that cannot override method in subclasses. So if it has got a subclass, then it cannot override this. So body of next move can't be overridden. Okay, there is another related keyword with this one, which is called super keyword. If your method overrides one of its superclasses methods, you can invoke the overridden method through the use of the keyword super. Now super, as the name suggests, that if you remember, parent classes are also called superclasses. It means that if you put super in the subclass, then you are not calling the method of that subclass, rather you are calling the method of the same name of the parent class, of the superclass. Okay, so you should look at these keywords, because these keywords define their own names. Like final means that it's constant, super means that it belongs to the parent class. So if you are using super, it automatically means that if you're choosing between two methods, that what kind of method you want to use. You should remember that when you are writing the code for a child class, you can also call the method straight of the parent class as well. Okay, so if you have overridden the method, I'll just give you an example, that if you have a draw method in the parent class, and in the child class in circle you have overwritten the draw method, and you have put your own definition or your own implementation in the draw method. Now the draw method which is in the parent class is different from the draw method in the child class. Now during the calling of the methods, if you want to call the draw method of the parent, then you should put super with it. It will automatically mean that you don't want to call the children method, rather you are calling the super method or the method from the super class. You can also use super to refer to a hidden field, although hiding fields is discouraged. So hidden fields are written in the parent classes, but they are totally discouraged, because you should to keep the data consistent and more readable, you should not have hidden fields in it. But of course there are methods to write hidden lines of codes as well. If that is the case in your program, then you can use super keyword to call those kind of hidden fields. Okay, there is this example of using super. There is a class super. So for the sake of it, I have named the class super class as well. And it has got a print method, and there is a subclass, so let's call it a subclass, and this subclass is extending superclass, and this subclass also has got a print method. If you look at the print method of the parent class, what it is doing is that it is printing out printed in superclass message, but the same method in child class is printed in subclass. Now the name of these two methods is same. One is in superclass and one is in subclass. Now if you are going to call in the main, what you have done in the main, that you have made an object of subclass. Okay, this is the instantiation process of making a new object s, and we are trying to call s.print method. So what is this gonna do? What it's gonna do is that it is gonna call the parent the subclass one, because this s is subclass method. But if you had put super with it, look at this thing, that in the subclass method we have written super.print method. So first you are calling this method will execute. So first it will call super.print method, which means that this print method will execute its behavior, which is printed in superclass. And you can see on the display, this printed in superclass will be printed before printed in subclass. So that is how you are doing it, because you are calling the super method first and then you are executing this message. Okay, now let's talk about generics. Generics are a powerful feature of the Java programming. What they do is that they improve the type safety of your code, making more of your bugs detectable at compile times. Okay, in a nutshell, generic enable types like classes and interfaces to be parameterized when defining classes, interfaces, and methods, much like the more familiar formal parameters used in method declaration. Okay, time parameters provide a way for you to reuse the same code with different inputs, and the difference is that the inputs to formal parameters are values, while the inputs to type parameters are types. If you have seen, if you saw them in the previous lectures, like there are methods in which we are passing some values. Now those values can have their own data types, but in this case those values are going to be the parameters, and they're going to be only the types. They're not going to have any variables attached to them. Okay, let's look at some of their example. For example, you have got collection interface. A collection represents a group of objects known as its elements, and the list interface is an ordered collection. The user can access elements by their integer index position in the list and search for elements in the list. And array list is, of course, is the array list of the interfaces, which is basically resizable array implementation, and it implements the size, isEmpty method, get method, set method, and it can also implement iterator method and list of all the iterator methods. Similarly, there is a concept of linked list, which you might have studied in object-oriented programming, where you can have a doubly linked list implementation of the list interface, and basically it is used to implement the size, isEmpty, get set methods, again the iterator and list iterator methods. So if you look at this example, you have got an interface which is java.util.collection, which actually defines a collection type with methods to manipulate a collection. Now you've got a specialized interface as well, which is of type list. It is extending the collection type by adding methods supporting indexed access to the elements. Okay, so collection is just a collection, but the list is actually implementation of the collection, in which you can have methods which can give you access to the collections. Interface list extends collection, by the way, and it has got two children interfaces, which two children classes, sorry, which is one of them is array list and the other one is linked list. So array list slightly different from the linked list, because in the array list you can implement all kind of methods which you implement in linked list in the array list as well, but their implementation is slightly different because the data type has got its own implementation type, and you implement these two constructs differently. For example, this array list is a resizable array, okay, and linked list is the doubly linked list. And if you remember these two concepts from your object-oriented programming course, then linked list is implemented using pointers, and arrays are arrays which are resizable if they are array list. Otherwise you can also have static arrays as well, but we are not talking about them here in this particular example. Okay, so if we look at the implementation example of list and list templates, then this is the example where we have got an object of list and we are making it array list type, and you can add hello to it, and then you have got s string list dot get 0. So in the array list, basically you can access these different letters from it. For example, the get 0 will bring you H, okay, and get 1 will bring you E, get 2 will bring you L, and so on and so forth. So it is a nice implementation of list, but it could be nicer because no typecast and better type checking. So what you can do is that you should make it with a string one. Now the list is string from the beginning. Okay, you're declaring this list as a string type. Because it is going to have a string character in it, this hello, string letter for it, so you should declare it in the beginning string, then it can save you a lot of confusions and it will make your code more efficient. So this list is new array list and it is again the type of string. So then you can add hello to it and it's going to bring the same kind of thing. But here if you see that you are not costing it, okay, you're not typecasting it. But if in the previous example you will have to typecast them, why you would have to do that is because you don't know what kind of data is in the list. Okay, so if you have trying to make this assignment of S with a string letter, then you should make it, you should typecast the value which is coming out of the list as a string. Only then you can declare it. But if you make it in the beginning, then you don't have to typecast it. And why it is important? Okay, this is the concept which is used in advanced object-oriented programming, and it is a very important concept. So if you are going to write complex system, you should know how to do this parameterized type of lists. Or you can use this parameterization with all other kind of data types as well. So the concept is that if you look at this example, this is a very simple and straightforward one. So you might say that there is not big difference in these two lines of codes. But if you are going to have a lot of variables of this list type, or if this list is going to be used multiple times in your codes, then you can imagine that how many times you would have to write string with it, or how many times you would have to typecast any variables which you are going to use for this list. So this string word, you don't have to write it if you have typecasted it in the beginning, or if you have declared it in the beginning. That list is only going to have string type of collection. So what will happen if you put different classes of objects in a list? Well, this is just the variables, but just imagine the situation where you're gonna put classes in that kind of list, then invoke find max on the objects in that list. So if you want to find that which is the maximum object, you would get a runtime error if the is larger than method for one class doesn't accept objects in other class as a parameter. So it can always happen, this type of situation can arise anytime if you are not going to write this kind of template, like if you're not going to declare it. And especially when you are going to make a list of classes, then you should always typecast it in the beginning. Well, this is not a typecasting, but this could be called as parameterization, or you are making it as a template. Okay, now let's talk about visibility rules. With classes, with interfaces, and with abstract classes, you must have seen that we write three different types of keywords. One is public, other is protected, and the third one is private. So what are these access modifiers? They are also called access modifiers. What they do is basically they give you the visibility of the methods with which you put them, or the classes, or the variables. So if you look at the access levels of these three modifiers, the public one is accessible by all classes, by the packages, by the subclasses, and by the world. So public means that you are making it public for everyone. Anyone can access that methods from other classes, from other packages, or even from other systems. Okay, if you have written a code in Java, and if that code is saved in particular drive, say D drive, and you're going to write another code and you're going to save it in the C drive, the second code can access the public classes of the first code. Or if you have written a code and you have got multiple interfaces in the same system, then all interfaces can access each other's public methods. So you should be careful whenever you use this public modifier, because our main purpose of using object-oriented programming is to bring data hiding. And if you are not implementing this data hiding process, and if you are declaring your data as public, it means that you are letting everyone know about the kind of value you are keeping in your variables. And then the whole purpose is lost, and all the methods and the variables and the classes become vulnerable of getting attacks from hackers, or there could be an illegal kind of access to the classes or to the data which is being kept in that classes. So you should be careful with using this modifier. Protected is sometimes suggested. Well, this is more like a public protected, but what it does is that it doesn't give access to the outside world. So if you have got other systems and you don't want to give them access to your system, then you can use the protected one. So, but still protected will give access to other classes, to other packages, and to all the subclasses. Okay, so the protected is also more like public. So if you want to bring in data hiding thing within your system as well, then then you should not use the protected one, because it will behave just like public. And if you don't have any modifier at all, then what is going to happen is that your classes are going to be visible to everyone, your package will also be visible, and your that key field or that method or that class is going to be accessed by any other class, by any other package, or but subclasses will not be able to access them, and the outside world will also not be able to access them. So what is suggested is that the best option to go with is private. What private does is that only the class, within the class, methods can access private data, but outside the class, even the package cannot access the private methods or private fields. Subclasses can also not access, and so cannot the outside world. So private is the best way of protecting your data, so that data will only be accessible to the objects which belong to that particular class. Even if that class is a part of a package and there are other classes in the same package, those classes won't have any access to the private data. Okay, so this is the access levels, and these are the modifiers, and you should be careful with the usage of these modifiers. So there are some of the tips which you can use if to choose an access level. If other programmer use your class, you want to ensure that errors from misuse cannot happen, so access levels can help you do this. And use the most restrict access level that makes sense for a particular member. Use private unless you have a good reason not to do so. Avoid public fields except for constants. Okay, constants you can make public because everyone is gonna use them. I gave you an example of mathematic constant pi. Now the pi's value is going to be used by all the other classes, and you should make it public because it's just a constant and its value is not going to be changed anyway. And you can also put public with final variables or final methods as well, because you know that if you have got a final keyword, then the values are not going to be changed anyway, so there is no harm in using public with them. And you should rather use the public with them so that other could use the values if you have put some constant values in them. Avoid public fields except for constant, and many of the examples in the tutorial use public field. This may help to illustrate some point concisely, but is not recommended for production code. Public fields tend to link you to a particular implementation and limit your flexibility in changing your code. So yes, so you should also be careful when you are using the access modifier, and if you don't want to, if the situation is such that you don't want to use private, then you can always use public in it. And if you're writing a small code and which is not sensitive and it's not going to have any sensitive data in it, then there is no harm in using public. So there is a topic in Java tutorial with the name controlling access to a member or class. You can look up this topic in the Java tutorial, which is given on the Oracle website, and you can read more about these access modifiers and their usage. Okay, now let's talk about packages. Now I have given you example of packages when we were discussing about object-oriented design. I showed you how you can use their notations, and I also showed you how you can show inheritance generalization in the packages, and there are multiple classes which you can include in a package, and how you organize them, how do you show their association with them, and what is the notation of the package. Now we will look at some of the codes. And well, package doesn't have a code of its own, but what it does is that it can keep other classes in it, so it helps you organize classes. For example, if within a system you are going to have different modules, and you had I gave you an example of a student information system. In that system you are going to have student registration, student finance information, and then student admission information, and students' results. So all these kind of modules are different parts of the same system. So what you can do is that these modules are going to have their classes of their own, and it is always recommended that if you have got this kind of system, then you should introduce packages in them. So one package could be student registration, the other could be admission, the third one could be finance, and you can keep the classes which are related to that particular package in their package areas. So this way what you are doing is you are grouping the classes, and as we studied before, that there are access modifiers which give access to the classes in the similar package. So it means that you can declare access modifiers in a better way if you have, or if you already have packages in the system. So packages are grouping of related types, as I told you before, providing access protection and namespace management. Note that the type refers to classes, interfaces, enumeration, and annotation type. So you can not only have packages for classes, but you can also have them for interfaces, for enumerations, and annotation types. Enumerations and annotation types are special kinds of classes. As we discussed before, I showed you some examples as well, and I'll show you some later too. Respectively, so types are often referred to in this lesson simply as classes and interfaces. Well, basically enumerations are kept within the classes, so you don't add separate packages for them. So in the normal routine, what you do is that you only make packages for classes and interfaces. So the purpose is to make types easier to find and use, to avoid naming conflicts, and to control access. Programmers bundle groups of related types into packages. When you are creating a package, then you should be careful that you choose a name for the package which shows its purpose, or which shows all the nature of the classes which are part of that package. So the naming conventions will be discussed here. Put a package statement with the name at the top of the every source file that contains the types, classes, interface, enumeration, and nation types that you want to include in the package. The package statement, for example, package graphics. Okay, for example, if this package is going to have only classes for graphics, then you can name it graphics. It must be the first line in the source file. So what you're going to do is that in every class you are going to write package graphics semicolon in the beginning to tell the readers that this class is part of graphics package. There can be only one package statement in each source file, and it applies to all types in the file. Okay, one public type per file. If you put multiple types in a single source file, only one can be public, and it must have the same name as the source file. For example, you can define public class circle in the file circle.java. So if okay, this is very important. Now, what is the file? What is the difference between files and packages? File is that kind of package where you're gonna keep all the package which has got the related classes in it. So the file is the file of your system. If you are going to make a system for ATM, then your file's name will be atm.java. Now that atm.java is going to have a lot of packages in it, but one package must have a name ATM. Okay, so and its access modifier should be public. So similarly, if you are going to have a circle.java file, then you should have public class circle in it, and if there is a draggable.java, then there is a public interface draggable. So this draggable is going to have packages for draggable. So the one package should name it should have the same name as the file name. Define public enum day in the day.java. So in day.java is a class, is going to have different enumeration packages. So one package should have name public enum day. You can also include non-public types in the same file as a public type. This is strongly discouraged though, because unless there is a public, non-public types are small and closely related to the public type, you should not use it. But only the public type will be accessible from outside of the package. All the top level non-public types will be package private. This rule makes it easy for the class loader and the human programmer to find the definition for a public type. The name of a package determines the directory in which the files of this package should be stored. The name of a public type determines the name of the file in which the type's definition must be found. So it is always important that the kind of a file you have and the name which you are giving to the file, you should at least have one same named package as well in that file. Okay, there are default packages as well. If you do not use a package statement, your type ends up in an unnamed package. Well, it is never recommended though. You should always have a package for similar types of classes. But if you are not going to have any package, you simply start writing the classes code, then it will automatically be kept in a package, which of course will be unnamed. Generally speaking, an unnamed package is only for small or temporary applications, or when you are just beginning the development process. Of course, if you are new to the programming and you are going to write a hello world code or a very simple code, or if you are professional programming but you are going to test some code, or if you are using an IDE for the first time, then you can simply write the code of a class. So what will happen is that that class will automatically be stored in an unnamed package, but it is never recommended. You should always start with a package. If you go to Eclipse IDE and if you start writing a new code in that IDE, you will see that there is a wizard which takes you step by step to write a simple class. That wizard, what it does is that in the beginning it asks you to enter the package code, so which shows that the package is very important to declare in the beginning. and if you don't do it, then it doesn't take you to the next step. So it is a kind of a mandatory to name a package in the beginning, and of course there is a convention that you should keep the name similar to the file's name. And if you don't do it, then classes and interface will belong in the unnamed package, and that is going to be a problem for you to understand and to read. But if you are just using it for simple purposes or for the testing purposes, then there's no harm in writing the class without a package. Okay, there are some conventions which are used. With programmers worldwide writing classes and interfaces using the Java programming language, it is likely that many programmers will use the same name for different types, because the fully qualified name of each class includes the package name. For example, java.awt.rectangle. There is no naming conflict unless two independent programmers use the same name for their package. The thing is, like, if a system is a very complex one and it is going to have a lot of packages, and then the developer team consists of many people and they are working from off-site locations. So what is going to happen is that if they name two similar packages with the similar name, then there is going to be a conflict, because two packages cannot have similar name in one file. Then it is always recommended that you should consult if there are different developers and they are working from different locations, and if they don't have communication between them, then there is going to be a convention problem, and then there is going to be a runtime error in that kind of situation. So to avoid that, it is always recommended that the package names should be consistent and there should be no two packages with same name in one file. And package names are written in all lower cases to avoid conflict with the names of classes and interface. If you have seen the convention for classes, then class name begins with the uppercase letter. The first letter is uppercase, and then there are lower cases. And if there are two letters combined, if two words combined, then both words are going to have first uppercase letter word. Okay, so the uppercase suggests that it is a class name. Similarly, when you are going to name interface, you use the same convention, that if there are two words used in interface name, then you should have first letter uppercase. So to avoid the conflict between classes names and interfaces name and the packages name, what you should do is that you should have all lowercase in the packages. And the companies use their reverse internet domain name to begin their package names as well. For example, com.example.mypackage for package name my package created by programmer at example.com. And name collisions that occur within a single company need to be handled by convention within the company. Of course, you can adopt different kind of conventions to save you from trouble of having conflict between the package's name. What you can do is that if there are multiple programmers working in the same class and they are creating their own packages, then they can have an extension to the name with their own ID or with their own last name or any kind of convention which can be adopted in a company, so to avoid this kind of conflict. Packages in the Java language itself begin with java dot or javax. Okay, external references. To use a public package member from outside this package, you must do one of the followings. First, refer to the member by its fully qualified name, and second is import the package member or import the member's entire package. So the fully qualified name for class C in package P is p.c. So this is the name. If you want to import this, then you should write it import p.c. P stands for package here and C is the class, so you have to name the full name. Okay, so sometime it is required that you want to access a different class from a different package, and you want to access a class outside of the package, then what you should do is that you can only call it with its package name, P, and the P stands for the package and the C stands for the class name. So you also have to write import keyword with it as well. Java gives you a great deal of control over the namespace of your program. For example, you control the import of external names by your import statements, and you control the export of your names as well by restricting the visibility in packages and inheritance. So this is an organized way of writing the code in Java, that if you look at the import of the classes or the methods of the classes, then the packages give you control over that. And if you look the export, and if you are going to give the access of a method, of a variable or class to another class in any other package or outside world, then you have got access modifiers to have that control. Keywords for control of inheritance. Every subclass will inherit all superclass members that are declared as public or private, protected. So the superclass is going to have, if the superclass has public methods or the protected methods, only then subclasses can access them. But if they've got private methods, then even the children cannot access them. By contrast, private members are not inherited, but may be accessible through super. Okay, because when you write super, it means that you're not accessing the method from the subclass, rather you are calling the method from its superclass, because super stands for parent's name. So you're not writing the parent's name itself, you are writing super, which is implying that it is the parent class. So basically you can do that, and you can even access the private members using the super keyword. The default visibility is package private, inherited by subclasses within the same package, but not inherited by subclasses that are declared outside the package. No subclass can override static methods, as I told you before, or override final methods. Any subclass may add new members. These new members could be fields or methods, or override any non-static and non-final methods in the superclass. So these are the rules which have to be followed if you are writing an object-oriented system. We say a method is overridden in a subclass if any of its superclasses has a method of the same signature, that is the name plus the number and the types of the parameters and return type. A return type should also be similar if you're writing the return code in your code, and if that return type is not matching with the return keyword which is written with the named method, then there is going to be a runtime error. Note that overriding does not absolutely prevent access. A reference to the superclass member is still possible. For example, with super, if this member is visible. That is why super keyword is avoided, because you can even access private members from the superclass as well using this super keyword. So it is not recommended, but of course when there are situations where you want to access the method from superclass, then you can use it. And if there is a situation when you have overridden a method of parent class in your own class, but you want to access the method of the superclass, then you have to use this super keyword. Now these are the rules which you have to follow, and if you are going to have private methods, that what kind of access modifiers you are going to declare and why you are declaring a particular member as private, so you should know that. And similarly, if you are going to give access to other classes, or if you are going to give access to the subclasses, then you should always declare the methods, the class and all the variables with public and protected access modifiers. And if you are giving access to the subclasses, then you should decide what kind of methods you are going to have in the parent class. Whether if you are going to have them static, then of course you are not allowing your children to override those methods. Similarly, if you are going to have them final, it means that you want to keep whatever the implementation they have got final, and you don't want it to be changed. So you should use these keywords carefully, because they can restrict access of subclasses. They can also restrict access of the classes in the same package. But if it is intended, then of course you can always use these keywords. And in the inheritance, you should also be careful when you are using non-static and non-final methods, because if you have got these kind of methods, then the children can always override them, and they can also add some behavior to it which sometimes is not intended, or which sometimes is not required. So you should restrict that kind of access by using these restricted access modifiers. So in this also there are, before going to the next topic, I'm gonna recap these packages, conventions, and how you use the package with the interfaces and classes, and how you can have multiple packages in same class, and how you can give access of the packages to the other files. Now, import is a very powerful keyword which you use here. With the help of import, what you can do is you can import the entire package, and you can give access to the entire package to the outside world. Now that outside world could be a part of your system, or it could be a different system altogether. But when you write import, but you should be careful, because all the methods which are public, or all the classes which are public, only those are going to be accessed from outside the world. So if you are intending to import some of your packages, and if you are intending to export some of your methods to other classes, then you should have the access modifiers accordingly. And in this we saw that if you are going to import a particular class, what you do is that you write the full package name along with the class, or you can also write p.static, which stands for that all the classes of this particular classes, all the classes of this particular package will be imported. So this is a wildcard, and there are many wildcards which you can use if you have studied them in object-oriented programming. They are applicable in Java as well. So this wildcard denotes that you are including all the classes. Okay, you are not writing a name of one class. But if you are intending to only import couple of classes, then you should only write import p dot names of those classes. So that was the import, and these are the rules which you should follow for object-oriented programming. So now we are going to review what we studied today. Today we talked about interfaces in Java, which we studied in the last lecture as well. Today we saw some other examples of interfaces, and we also saw that there are some key variables, some keywords which you can use, and we also saw that what kind of different modifiers you use to restrict access to the members of a particular interface. And we also saw that what are the types in Java. We saw in the previous example as well, or in the previous lecture we showed you some examples of using interface as types. Now when you are using interface as type, you should be careful that you should implement them in only implementing classes. Okay, the classes which are part of that interface, because if you do that outside, then you're gonna get some runtime error. To avoid that runtime error, there is a keyword instance of. You can use that keyword to find out if the particular class belongs to an interface, and if it doesn't, then you can handle this by using exceptions and by writing the code for exception, and the whole system will not crash. Rather, you will have a compile time error, and the exception will be thrown, and whatever the message you have written in the exception, only that will be displayed on the display screen. Then we also studied abstract classes in Java, and I showed you that sometimes it is recommended, or it is sometimes there are some situations when you don't want to implement some methods, rather you want to have them for your children, and the children classes can override them. So in that kind of a case, you can introduce abstract methods. You can also declare that class as abstract, and then what children can do is that they can add implementation according to their own needs. And abstract classes and abstract methods can be added in any program wherever you want to have an extended implementation of methods, where you want to have different subclasses to have their own implementation. So you're not restricting them to use parents' implementation of a particular method. Rather, what you want is that they can override it and they can add some extra behavior to it. But you should also be careful that when you are using abstract methods, then they are not going to be overridden as they are, or they're not going to be used within the subclasses, because they are abstract, they don't have any implementation, or they don't have proper implementation. So of course the subclasses cannot use them as they are. So you should be careful whenever you put abstract keyword with any method, then it is only the situation where the same method is being overridden in the subclasses. Then I gave you an overview of the generics in Java. In generics, we studied some collections. So if you want to have collection of variables, or if you want to have a collection of classes, then you can give it a type. Now that type is very important, because if you don't do it, then you will have to do a typecasting. So that a typecasting can add some more code to it. And if you have got a very simple system, then typecasting is not an overhead. But if it is a complex system, then it could be inconsistent if you don't add it, because then you will have to add it with every variable which is part of that collection. So it is recommended that whenever you are initiating a collection, at this very point, you should mention that what kind of collection, what kind of items this collection is going to have. So if you declare that, like the example I showed you, if you declare it string, then all the elements which are part of that collection will have string values in them, and you will not have to typecast them whenever you are using them. Then in the end, we studied packages, and we saw that package itself do not have any implementation. Rather, they are just group of similar classes or similar interfaces. What you can do is that you can add similar classes in a package. You can name it according to the classes it is going to have, and then out of all the packages, you should have at least one package that has a similar name to the file name. And just to keep the consistency in the system, you should adopt this convention. So this was our lecture today, and we covered these important constructs and important concepts of object-oriented programming. In the next lecture, we are going to look at some other object-oriented design constructs and how you can implement them in Java programming. I would suggest you to implement all the example I showed you in these lectures in your IDE, in Eclipse or JBuilder, and I think I suggested you Eclipse in the previous lectures. Eclipse is a very good tool because it has got IDE as well as a drawing editor. So what you can do is you can draw all your design diagrams and then you can connect them with your code. So Eclipse does that for you, and Eclipse also allows you to make executable models as well, executable diagrams as well, which can eventually generate code for you. So it is always good to use this kind of a tool. So you should take this example as they are from these slides and try to implement them in Java editor and try to run them and see that how they play, and if there is an error, try to correct that error. And I would also suggest you to add some exception handling in this as well. We have not studied in detail about exception handling, but what you can do is you can go on Java tutorial and you can read more about it, and you can take the code as it is from that Java tutorial and you should try to implement it and see that what it does for you. And this exception handling is a very important concept in object-oriented programming. So this concludes our lecture today, and we will meet in the next lecture with a new topic. Until then, Allah Hafiz.